Any doubts? Then now just look here. The next topic of interest for your syllabus is Eurodan methodology. Requirements of drawing on is not there. So next we'll go with the Ward-Miller method. Ward-Miller method, very important. Ward and Miller method. So the outline of Ward and Miller method is shown in figure. So this is the outline. The entire abstract model, we'll try to divide that abstract model into two. First one model is called as environmental model. The second model is called as behavioral model. So in the environmental model, what happens is that we'll write the description of environment. What is the type of system I'm going to design? What is the context diagram? What is the description of boundary separating the system from its environment? How to develop the uh, uh, system considering the external environment means the people will interact with the system. How many people will interact? What is the objective of my design? Where exactly the design fits? So that is what is the environmental model. So then event list, what type of external events will occur, whether I have to monitor the temperature, whether I have to monitor the pressure, whether I have to monitor the light intensity, or whatever may be the external environmental factors, I will treat as an event. I will treat as an event. If there is a rise of temperature, my system has to identify means the first event list is to check the temperature outside of the device. So that is important. That is important. That's what is the event list. Description of external events in the environment to which the system must respond. So basically, we'll try to divide the system into two parts. First part is environmental model. Second part is the behavioral model. So abstract model, we'll classify that into two parts in Ward and Miller methodology. The environmental model, where we describe the environment. So in that, we'll further categorize into context diagram and event list. On the other hand, you can see that the behavioral model description of behavioral response to environment. So transformation schema, what type of logic things I have to do. Description of the actions taken by the system in response to events. What is the description of the events? What is the description of the actions? If the event occurs, what actions have to perform? Say for example, you are designing a fire alarm system. Then fire alarm, okay, fire has been identified now. Fire has been sensed by the list. The fire happening is the event. So your sensor has sensed there is a fire. Then what type of action you are doing? Whether you are opening a valve to water that entire area where the fire was caught. So that is what is transformation schema. Description of the actions taken by the system in response to the events. That is what is important. What actions have to take place if an event occurs. Data schema, what type of data? Description of the information the system must have in order to respond. If there is a fire, I have to open a valve. That you have to write it in a data schema. For this, we have a very good, interesting video. Just I'll show that video. Ward and Miller methodology, very famous methodology. This methodology is called as Ward and Miller. Wait for a while. Ward and Miller. Wait for a while. I'll just share the video. You can see here. So this is what is the methodology. So first one is building essential model, then going with the environmental model. This is the two parts are environmental model and behavioral model. This model describes the relationship of the system with its environment. So environmental model, it mainly comprises of context diagram and event list. This method describes the relationship of the system with the environment. So you can see here, a context diagram is a top level, also known as level 0 data flow diagram. This is a very basic type of diagram. Level 0, that means scratch, I don't know anything. The first thing is to write the data flow diagram. A context diagram, you have to write process, external entity, external entity, external entity. I don't know anything about the environment. I want to monitor it. So first write the context diagram. So it only contains one process node, process 0, that generalizes the function of the entire system in a relationship to the external entities. Or how many systems or how many events I want to control, I don't know. But first I know, first you have to write the context diagram. Context diagram, this is the process that is happening. So we have some 5 events. Say for example, I have 5 entities to be taken care in the Warden-Miller method. So this is the first type of. Then if I go with a drying oven controller, so if I want to conventionally, I want to control the oven, or else I want to design a system that is a oven system. So temperature transducers, oven temperature, it will sense the oven temperature. Heater units, heat output. So what is my context diagram? So this is an example of drying oven context diagram. So context diagram, drying oven controller, conveyor speed sensor, safety guards, conveyor fault sensor, guard lock, conveyor motor controller. So now if you just take an example of an oven, a large oven, so it is which is to be controlled by computers. So this is my context diagram. I want to control the following things. I want to have a control unit for entire drying oven controller. So this is the context diagram. So the first context diagram is the this thing. So you can see here, this is the process to be happening. The process here is drying oven process, and the external environments I have to control is. So these are the external environments I have to control. So I have to control the temperature transducer. I have to go with the speed conveyor, that is conveyor speed sensor. I have to go with the safety guards, conveyor fault sensor. If there is any fault in the conveyor, what I have to do? So this means you have to write the all the possible cases of the operation. All possible operation or all possible operating procedure has to be completed here. So you can see here, if I want to convey, if I want to control the conveyor speed, so it will control the conveyor speed. So this has to be all the things which have to be which are happening has to be written in a proper context diagram. So context diagram is very important. So writing this context diagram is very important. Why? Because here we are trying to mention each and every single simple task which is to be controlled. So for example, if I want to have an operator console, I want to display the unit, whatever is coming out of the system, and I want to give some commands so that I can control the entire entire oven. So this is what is to be considered while designing any Ward-Miller methodology. Ward-Miller methodology, if you follow, you have to divide it, and you have to you are controlling the external environment. You're controlling the external environment. That is to be remembered here. Okay. Any doubts? Okay, then we'll move on. Rectangular boxes gives the terminator blocks, which are entities exist in the environment. Here, system is given a single bubble. Directed lines represent data and control information that is passing between the system and the environment. So you can see that Rectangular boxes are the terminator blocks. No need to worry about this things. And the entire system is a bubble. Entire system is given as a bubble. Okay. So you can just go through this and you'll come to know. Okay, this is about your wadded Miller methodology. So any doubts? Okay, if you don't have any doubts, you can mark your attendance. Okay, thank you very much. You can leave the class. Swati, Anikita, Saniha, Shringa.